There we go. All right. Yep, adjacent over hypotenuse was cosine. And then, thanks, Eduardo, cotangent is adjacent over opposite. All right, so hopefully this kind of helps jog our memory a little bit of what our 6 trig functions are. So if we were to look at a right triangle here, and we'll say that this is the angle that we're thinking about, theta. This would be the opposite side. This would be the adjacent side, and this would be the hypotenuse, since it's across from the right angle. So remembering which side is which is important. And then let's say that this one has ratios of 3, 4, and 5. Or sorry, side lengths of 3, 4, and 5. Oh, no worries, Maddie. Yeah, they made a new Google Classroom automatically for the new quarter. So yeah, we get a new one with some familiar faces and some new faces. That's fun. All right. Anyway, so if we had these side lengths for this particular triangle, then sine would be the ratio opposite over hypotenuse. So in this case, it would be 3 over 5. Cosine would be 4 over 5. Tangent would be 3 over 4 for this particular triangle. And then these ones are all the reciprocal right triangle trig functions. So in order to get cosecant, you flip sine over. In order to get secant, you flip cosine over. In order to get cotangent, you flip tangent over. Okay. So hopefully this kind of jogged our memories a little bit from where we were back in geometry and in advanced algebra trig. And today is just going to be kind of a very basic overview going back to how we solve for sides, how we solve for angles, how we do word problems using right triangles and stuff like that. So hopefully this kind of eases us into the semester, or to the quarter. I keep saying semester, but we're on quarters at the moment. So anyways, another way that you can think of these then is this is like 1 over sine. This is like 1 over cosine. This is like 1 over tangent. So these are all reciprocals of their originals. Okay. So then going back to kind of solving right triangles and stuff like that we did in geometry and maybe a bit in advanced algebra trig as well, we're going to do a couple of examples where we have partial information about a right triangle and we find the rest of the information about it using trig. So here we go. Example 1. This is going to be an example where we are solving for missing sides. So we're going to be given this right triangle here. We know this is a 47-degree angle. We know this side length is 6, and we are missing these 2 sides. Okay. So there's a couple different ways that you can go about this. One of the ways you could think about it is you could find this other missing angle and then use the same trig function to solve for both of your missing sides. The other way that you could do it is you could notice, okay, this is the angle that we have. And so if I label the sides with respect to this angle, we have the opposite side, we have the hypotenuse, and we have the adjacent side. And it just so happens that the adjacent side is the one that we know the exact length of. So if I look up here, the 2 that involve the adjacent side would be cosine and tangent. So that means I'm going to use cosine and tangent and set up an equation that involves both of those, or set up 2 equations actually. one to solve for x and one to solve for y. So the first equation I'm going to set up using cosine. Well, I know that cosine of 47 is adjacent over hypotenuse. So that would be 6 over y. So that's going to be my first equation, and I would solve this equation for y. My second equation is going to involve tangent. We know that tangent of 47 is opposite over adjacent, so x over 6. So that's the other equation that I'm going to use to solve for x. So from there, what I would probably do here is just then start solving, multiply by y on both sides. So we get y cosine of 47 equals 6. And then I would divide by cosine of 47 on both sides. And then you're left with y equals 6 over cosine of 47. That's where you start typing things into the calculator. Let me find a calculator here. All right, it's in. Also, make sure if you're using a calculator like this, for now anyway, you're going to want to make sure it's in degree mode. Desmos already comes in degree mode, but sometimes TI calculators start in radian mode, or you might have put it in radian mode when you were doing radians some other time. So for right now, we're going to leave it in degree mode. If you need to change it, you can just hit mode and hit degree. But as we move on throughout this week and next week, you are going to start switching things into radian mode and working with radians. So you'll want to pay attention to what mode your calculator's in, depending on the problem that you're doing. So yeah, sometimes we start getting weird answers when we deal with things in degrees versus radians because we forgot to fix our calculator mode. So just watch out for that. But for today, it's based on whatever the problem that you have, what kind of units you're given. So like, for example, in this one, it says 47 degrees. So that's how I know I need to work with degrees. But if I had a problem where it said something like we want the area of the sector of the circle that is given by the angle pi over 6. That would be a clue to use radians. So usually if there's pi's involved in your angle, that's another clue that you're working with radians. But whenever there's a degree symbol, you want to use degrees. And we'll talk about, later on this week how to convert between the two as well. But that's getting a little bit ahead of ourselves. So anyway, we're in degree mode for today and tomorrow. We'll talk about radians, I think, on Thursday. So 6 divided by cosine 47, enter. We get y is 8.797675, a whole bunch of decimal. And for this, sometimes you'll be asked to round to the nearest tenth or the nearest hundredth or the nearest thousandth. In AP Calculus, for those of you who will take that, you'll want to round to 3 decimal places at all times, unless you're asked for the exact answer. So it is a good idea to get into the habit of rounding to 3 decimal places, unless it is requested otherwise, like IXL might request only 1 or 2 decimal places or an exact answer sometimes. So in this case, I'm going to round to 3 decimal places. So we'll get y equals 8.798. So that's part of our answer. The other part of our answer is going to be when we solve for x. And this one's a lot easier because x is on the top. So all we have to do is multiply by 6 on both sides, and then type 6 times tangent of 47 into the calculator. And I know the calculator is kind of dark and hard to see, so sorry about that. but 6 times tangent of 47. Rest assured, that's what I typed in. So we should get 6.434 in this case. And again, if you're asked to round to something like the tenths or the hundredths, you can always round to less decimal places, but I tend to prefer 3 decimal places since that's what you'll do next year in AP. Okay, so looking at that first one was solving for sides. Are there any questions, any numbers we're not sure where they came from, steps we're not sure why or how they happened? Okay, and if at any point you do have questions, feel free to type them in the chat as we go or unmute yourself and say so. And if I'm ever going too fast or something like that, you can always let me know as well. Sometimes I get excited and start talking fast. Let's see. Also, there's another method you could use to solve this using the Pythagorean theorem once you find one of the sides. A squared plus b squared equals c squared. If you would like to, once you've solved for one of the sides, like once I got y, for instance, I could say that's y, and then go 6 squared plus x squared equals 8.798 squared, and use that to solve for x if you would like. But I find the trig method to be just as quick and efficient, but to each their own. You can decide. So from there, we've solved for sides. Now we're going to do one where we solve for angles instead. So, second example. Solving for angles. All right, so for this one, we're going to be given this triangle instead. And we're missing 2 angles. And we have 2 sides. All right, so to do this, you do need at least 2 of the sides. You could solve for the third side if you wanted to using the Pythagorean theorem, but it's not completely necessary. So first one we're going, and actually on this one, you really only need to solve for one of the angles using sine, cosine, and tangent, because once you've got 2 angles on a triangle, then you can find a third by subtracting from 180, or in a right triangle by subtracting from 90. So anyway, we can pick which angle we want to start solving for. I'm going to pick X. You could start with Y if you'd like to. But once you pick an angle that you're starting to solve for, you want to label your sides with respect to that angle. So, for example, this one is the adjacent to X, and this one is the hypotenuse. So if we have adjacent and hypotenuse, we are going to set something up using cosine. So anyway, setting something up using cosine here, we know that cosine of the angle X is equal to the adjacent over the hypotenuse, which is 12 over 13. Problem is, I can't plug cosine of X into the calculator and get anything meaningful out. Does anyone remember what we're supposed to use instead? No, it's probably been a while. Trig identities, inverse. Yeah, inverse of cosine is what I would use. Seen a lot of good answers there. Yeah, so what I would do on both sides instead is go cosine inverse, because that's what undoes a cosine. And so then we get x equals cosine inverse of 12/13. And that is something I can type into the calculator. So it might be a secondary function in your calculator. Or if you have this one, you tap the button twice and it gets you the lower function there. But then you go 12 divided by 13 and you get 22.61986. So that would round to 0.620 degrees. So that's part of our answer. That's what x is. And then once you've found one of your angles, you can go 90 minus 22.620 and get 67.380. So y would be 67.38. Or 0.380, but sticking an extra zero on there is not really doing anything for us. So there we go. We've solved for sides, we've solved for angles. Any questions on that one? Any numbers that don't quite make sense or we don't know where they came from? Alrighty. Well then, this is the part where we're about done. So we're gonna get our assignment now. And today's assignment is going to be brought to us by IXL. So a few things about logging into IXL, which I'm sure most of you have done by now in the year. Make sure you log in using Clever. Make sure you log in before you start doing problems or it won't save your progress, and that's sad. And then we're going for smart scores of 80. So on homework assignments, you can always go higher than 80 if you would like to, but I would like at least a smart score of 80. We've got M5 and M11 under pre-calculus that we're doing today. So I'm going to hit assign, and then you might have to refresh Google Classroom, and we'll take a look at a couple typical problems from these. So the first one is hopefully super simple. Yes, that is where I would like to go. Okay. Thank you, Internet, for being concerned. So it'll say like find the secant of angle W. So if we remember, secant is hypotenuse over adjacent. So we would go 17 over 8. So you grab your fraction button, 17 over 8. If you can reduce the fraction, you should. And let's see, then for this one, the tangent of angle B, opposite over adjacent, so 12 over 5. That's pretty much how those ones are going to look. It'll ask you for any of those 6 trig functions. And then the other one, yep, that's where I'd like to go, is M11. We're going to be focusing on finding side lengths for this one. So it'll give you one of the side lengths and an angle. And you're going to find, let's see, it says write your answer in simplified rationalized form. So this one, they do want exact answers and things like that. So some calculators will give you exact answers and, you know, make it exact for you. If you're in Desmos, there's if you haven't discovered this yet, I think it will do it. Like if I said sine of 60, oh, it doesn't have the convert option. Bummer. Oh well. Let's see. So as far as finding things in exact form, well, if you remember special right triangles, that'll help on this one. If you don't, then let's see. It might be okay actually if we, it'll be sine of 60 is, or wait, we want GH, just kidding. So cosine of 60, because that would be adjacent and hypotenuse. So you'd end up with 12 root 6 times cosine of 60. So you should, okay, well, cosine of 60 is 1/2. So sometimes occasionally on some of these, you'll want to type in the trig function first. Like, for example, cosine of 60 is 0.5. And then when you multiply 0.5 or 1/2 by 12 root 6, that would be 6 root 6 because, 6 is half of 12. And that's the way that they would like you to put your answer. All right. Let's see if this one is, I might end up changing the section depending on how much special right triangle this ends up being a review of. Sorry, guys. One moment. Okay. For this one, I will also accept the geometry version of this section because the geometry version of the section doesn't have quite as much fiddliness with the making sure that your answer is exactly simplified the way that they would have you simplify it. So let's see, what section was that called? Geometry R8. So you could do M11 in pre-calc if you would like the challenge. If you would prefer to not have as much of a challenge, say, or geometry R8. Okay, so you can pick pre-calc M11 or geometry R8 for that. Okay, any questions before we go today? Okay, so if you have questions or need help with anything, you can stick around. I'll be in this Google Meet for a little bit if you decide you want help later. Otherwise, have a wonderful day, and I'll see you all tomorrow.